Okay, so hopefully me walking through this will be helpful. I'm going to mark on my screen and maybe that will help too. So for number one, the object is moving away from the origin at a constant speed. So what you have actually graphed right here is not velocity over time. You've graphed position over time. Because what happens is the distance or position the person is getting steadily farther and farther and farther away. So that's what you've actually graphed. Whenever we have a velocity graph, I kind of draw it like this to make it a little bit easier with a positive up top and a negative in the bottom. But the key part of the sentence is constant speed. So that's like your cruise control. In this case, because it's moving away, we assume that it's kind of positive. And anytime we see positive or moving away, it's going to be in the right direction. But regardless, it's positive. So a constant in the positive direction is going to be just a horizontal line. I tried to change the color, it just won't let me. Is going to look something like this because it's just going to be a flat line. These two graphs kind of go hand in hand. The one on the left that you drew is actually position over time, and the one on the right is velocity. So constant speed just means cruise control. So velocity is like the speed of the car, so it needs to remain constant. There can't be any kind of slope or increase or decrease. In number two, the object is standing still. So again, in this instance, you've drawn position over time. If it's standing still, then it's just flat and level. It's not getting any farther away, and it's not getting any closer to where it started. If an object isn't moving, again, velocity is just a fancy way of saying speed. If it's not moving, its speed is 0. So you would actually have kind of a horizontal line right on the x-axis. It's just not moving. Whereas on the position graph like you did, it would be flat. It just wouldn't necessarily be at 0 if you had gone somewhere or were going somewhere and then stopped. Okay, so number three, the object moves toward the origin at 10 seconds and then stands still for 10 seconds. So in terms of that one, I guess I can kind of draw over here because we have space. If they're moving toward the origin means that it's going back. So that means that it's negative. At 10 seconds, then stands still for 10 seconds. So if it's walking back toward the origin, that means that it has some kind of velocity or speed. We just don't know what it is. We just know that it's negative. So at whatever 10-second time point, it's going negative, back towards wherever it came. And then it stands still for 10 seconds. So if it's standing still for 10 seconds, then you would have it be right at 0, because then it's going to essentially be, for that 10 seconds, look like number 2. What you have given here, I don't even know. I'm sorry. I would like to say that it looks like the position graph, but it doesn't. If it was the position graph, just kind of showing you what the position graph of that looks like, if it's walking back toward the origin, think of the x-axis is kind of the origin point. So there's some distance away, it would be walking back towards it for 10 seconds, and then it would not be moving for 10 seconds. So that's kind of what those two things would look like if we were just looking at number 3. So lastly, number 4, the object moves away from the origin, okay. This one is it's going away for 10 seconds and then comes back for 10 seconds. So similar to number 3, or at least how you've written it, if it's moving away from the origin, that's positive. If it's moving back to the origin, that's negative. So for about 10 seconds, it's moving at some kind of positive, I guess, speed. We don't exactly know the real value, but it's going positive. And then it moves back. So that means it's got a negative velocity at that point. If it's got the same speed, what that means is, like, if I arbitrarily put this at 10, that this is also kind of arbitrarily at 10. They're the same speed. The only thing that's really different is that the top one is positive or going in the right direction, whereas the bottom one is negative or going in the left direction because it's going back towards home. Otherwise, that's the only difference. And on a graph, often you would see this kind of as a dashed line or a solid line, just because in real life, like, that can't happen. At some point, there was at least like a fraction of a second that it took to turn around, right? But in this case, we're just showing an abrupt shift, so you might see that as a straight line. I don't know if that helps, but if it still doesn't and tomorrow you need some extra help, please let me know and we can schedule a time to meet.